For as long as human memory, we have been trying to understand ourselves, to understand our place in the universe. In order to understand our home, our planet, we have to put it in context. We have to understand the environment that our planet sits in, the solar system. The sun is a crucial part of Earth's environment, providing the planet with light and energy. And whilst it's very easy to observe our sun today, understanding what it would have been like in the past is not so simple. To do this, we have to look out into the universe at young stars that we know will eventually turn into suns themselves. The sun today has very large clouds in its atmosphere called prominences. By observing young suns, we see that these clouds would have been 100 times the size they are today when the sun was just maturing. On these young suns, these clouds can live for a few days, but eventually they're ejected into the solar system where they can collide with any orbiting planets and even strip away their atmosphere. This raises the question then about how life on Earth survived and why our planet still has an atmosphere. I don't have the answer for you, but if we want to find out the answer, then we need to better understand this aspect of the sun's life. We need to understand how these clouds form and how they're ejected. And this requires more observational data. But my models of these stars show that we can't just rely on the observations, because many of these clouds will never be seen with current observational techniques. Astronomers observe these clouds by looking for dips in the brightness in light as the cloud passes in front of the star. But what I've found from my modelling techniques is that in many cases, only a very small fraction of the cloud ever actually passes in front of the star. Most of the cloud doesn't, so it doesn't block out any light, and therefore the astronomers don't know that it's there. This means that predictions of the size of these clouds can be drastically wrong. In fact, in many cases, the cloud might not actually be seen at all, making them invisible to any observing astronomers. Because observations have been underestimating how big these clouds are, we've been unaware how much of a role they're playing in the environment of young solar systems. Now we know that when we observe these clouds, we need to keep in mind we're only seeing a very small proportion. And knowing this should help us make better estimates of how these clouds could influence the early solar system, and maybe even our own planet's development.